Okay, so currently I'm at a restaurant and I just figured I'd record this video. That way you at least have something. But this is going to be more about the conceptuals of derivatives, not necessarily anything beyond that. I'm not going to do anything complex. For this derivative, we're just going to do y is equal to x squared, which is really simple. And this is obviously the graph of y equals x squared. So you can think of like the first formula as being distance, right? Like, like a distance versus time graph, that's really easy. Obviously, this curve is going to give you speed. So this is, or velocity, you can think of. Let's say, so speed is equal to x, well, sorry, not speed, sorry. Let's say that is like the distance traveled is going to be equal to x squared, right? Well, when you derive this, this is the change in distance over time, right? Here's distance on the y-axis and then time on the x-axis, right? So what deriving really does is, obviously, what is the derivative of x squared? That's pretty easy. That's just going to be 2x, right? Well, what does that 2x represent? That actually represents the change in speed over time, right? So now we have speed over time, right? So you can think of that, let me dx, right? So x squared becomes 2x is equal to the speed, right? And here's our next graph, and that's going to be represented as 2x, which at 1 is going to be looking like this, something like this. It's going to be a straight line, like that. Boom. And this is the graph y is equal to 2x, right? So this graph represents the change in speed over time. As you can see, speed consistently increases at a constant rate, right? So we can put, speed is equal to 2x. Shit, hold on, sorry, my writing. Speed is equal to 2x, right? So, the question is, what happens when we derive this? What is that going to give us? And if you haven't got the pattern already, that is just going to give us acceleration. So if you derive 2x, all that's going to do is give you 2, right? So 2 is equal to the acceleration. So how does that look on a graph? Like, what is that? Why is it a constant, you might ask, right? Well, it actually intuitively makes sense. That means that the acceleration is just going to be a constant 2 throughout the duration, right, of this graph, right? So basically, like, to think about it conceptually, all like derivative does is it kind of gives you like the next tier of thing. I know that sounds weird, but if the initial formula, you can think of it as like the distance formula, then when you derive it first, that's going to give you speed. And then when you derive that again, that's going to give you acceleration, and so forth and so on. Just to put it in like physics terms, kind of basically. This kind of intuitively makes sense, as you can see in the distance graph. The distance is growing at at an accelerated rate, you could say, right? It's not going constant. It's curved because it's an x squared graph, right? So it's it's kind of increasing like that, a little bit like exponentially, or it's accelerating, right? And then the speed, on the other hand, right? The speed at any given point is increasing, as you can see, but it will be increasing at a constant rate, which would make sense because you would represent it as a straight line, or y is equal to 2x, And then finally, the final graph is just the acceleration. Shit, my handwriting is ass. Acceleration is equal to 2. And we know that this is true because at any given point on this graph right here, the acceleration, like it's constantly increasing, at a rate of 2, the acceleration throughout the entire duration of time, and that would appear on a graph simply as a straight line. So I don't know if that helped at all or if that confused you even more, but basically, yeah, I might send you this PDF if it helps at all, but basically, yeah.